Okay, let's dive right in. We're going to talk about one of the biggest, and I mean biggest, hurdles for AI right now. It's terrible memory. You've totally felt this, right? You're having a great, long conversation with a chatbot, you've given it all this context, and then, poof, it completely forgets something you told it just a few minutes ago. Well, it turns out there's a fundamental technical reason why that happens, and it's a massive bottleneck for the entire field.
So the heart of the problem is something called quadratic scaling. It sounds complicated, but here's a simple way to think about it. Imagine you're at a party. Every time you meet someone new, you have to introduce them to every single person you've already met. The first few introductions, easy. But by person 20, it's chaos. That's kind of what an AI is doing with every new piece of information, and it just gets computationally impossible really, really fast.
To really get this, we gotta think like an AI. And for an AI, language isn't words and sentences. Not really. It's made of things called tokens. Just think of them as little Lego bricks of language. And the more of those bricks it has to juggle, the harder it is to build anything coherent. But what if we've been feeding the AI language in the absolute worst way possible? A really brilliant new paper from the folks at DeepSeek-AI proposes a totally different approach. They're asking a pretty simple question. What if the AI could just look at the text instead of reading it token by token? Okay, so look at this block of text. For a normal large language model, this is about 1,000 of those little text tokens. 1,000 individual Lego bricks that it has to process one by one by one. It's slow and it's super expensive in terms of computing power. Now, here's the wild part. What if we just take a picture of that exact same paragraph? Well, that single image can be represented by the AI using only 100 vision tokens. We just went from 1,000 tokens down to 100. That's a 10x reduction in complexity, just like that. And that right there is the core idea. They call it optical compression. You're basically using an image like a super efficient zip file for text. Instead of spoon-feeding the AI a long, clunky chain of words, you just show it a picture. It's so clever. Of course, a cool idea is one thing. You've got to prove it works. So to put this whole theory to the test, the research team went and built a brand new model, and they call it DeepSeek-OCR. It's got two main parts. First, there's the deep encoder. This is the new innovative piece of the puzzle. It's like a super scanner that looks at the picture of the text and creates that tiny compressed summary of vision tokens. Then, you have a pretty standard language model decoder. Its job is to be the translator. It takes those compressed vision tokens and turns them back into normal text the AI can actually use. But the real secret sauce is inside that deep encoder. It works in this really smart three-step process. First, it scans the high-res image to perceive all the fine details. Then, and this is the key part, it aggressively compresses that visual information, shrinking the number of tokens way down. Finally, it feeds those few supercharged tokens into another part of the model to understand the big picture. So it's reading and compressing at the exact same time. So, this all leads to the million-dollar question. Does it actually work? I mean, it's a great theory, but can you really squish text down that much and get it back accurately? Well, the researchers ran the numbers. They started by taking documents and compressing them at that 10-to-1 ratio. So again, 1,000 text tokens get turned into just 100 vision tokens. And they found the model could rebuild the original text with an incredible 97% accuracy. That is almost perfect. I mean, that's nearly lossless compression, which is just wild for such a radical approach. So, being researchers, they had to push it. They cranked the compression up to a crazy 20-to-1 ratio. And even then, the model still got about 60% of it right. And that's really important because it shows the method is robust. It doesn't just fall off a cliff. It degrades gracefully, which is exactly what you want to see. And when you stack it up against other models, the results are even more impressive. Just look at this table. The small DeepSeek model gets better results than GOT OCR while using less than half the tokens. And check out their big model. It actually beats the massive minor EWU model while using almost 90% fewer tokens. It's not just a little better, it's on a whole other level of efficiency. Okay, so we know it works, and we know it's incredibly efficient. But this isn't just a neat party trick for reading documents faster. This idea could fundamentally change how we think about AI memory itself. Because here's where it gets really mind-bending. This technique might just be the key to giving an AI a memory that works more like ours does. The paper itself says this could create a kind of memory decay that's a lot like how humans forget things over time. Think about it this way.
An AI could store its most recent conversations as high-resolution, low-compression images, making them crystal clear. But as those memories get older, say a day ago, a week ago, a year ago, it could re-render them as blurrier, more compressed images. The distant past fades and takes up less space, while what just happened stays sharp. It's a natural, efficient way to forget.
So let's just recap what this all means, because it's a huge deal. This is a brand new path to solving that long context memory problem. It's a way for AIs to have a memory that's theoretically unlimited, but still efficient. It's also a cheaper, faster way to create training data. Bottom line, this could lead to way more efficient and powerful AI systems across the board. All of this leaves us with one last, really big question to chew on. We are just scratching the surface of how AI can combine sight and language. If it can start using vision to remember, what else could it learn to truly see?